And we're talking today about the rational numbers on a number line, and that starts on page 4 of your textbooks. Page 4 on your textbooks. In your textbooks, I should say. And then in your notebooks, you can, so if you were on the back of a page, now might be a good time to go to the next page because this is a new lesson. And what I'll have us do, I think we'll draw a big number line here. It should span the whole width of that page, so don't make it really tiny because then the things we're going to try to fit in it won't be very neat and nice for you. It's a number line, so it has infinitely going both directions there. And in the middle of it, you're going to put the number 0. In the middle of it, 0. We'll just start off with that. And then you're going to go all the way to -4 and +4. But you're going to leave room in between, leave a good space, and try to even it out as best you can. So this is what I don't want to see on your number line. That's not good management of your space. You need to spread those out. So kind of give it some space here. 1, 2, 3, 4. 1, 2, 3, 4. Now, if you notice what I did on the board, Mr. A took just a little bit more time, but kind of spaced it better. It's not perfect, but it should be usable. And then label your points or your tick marks. Okay, and then we'll talk about a few things here. This is review, I hope. I hope this stuff is not brand new, like, this is a number line? This is what, oh my. Then we're back to square one. Pardon me. Go ahead and draw that out, and we'll get started in just a moment. Hello? Okay, yes, I can. Bye. Avery, you're dismissed. I'll have this recorded so it's accessible. Okay, first thing I want you to do is this. I want you to put the number 3.25 on that number line. Where would 3.25 go? I'll do it in a little bit. So you do it on your own paper, and then I'll do it on the board. 3.25, 3 25 hundredths. So here's 0. 1, 2, 3. And then 3.25, I'm going to put it right about here. And then just put a dot, and then above it, 3.25. That's what I want. 3.25. All right? Now I want you to put -2.5. -2.5. And do the same thing we did up there. I'll try to make this clearer for that 3.25. -2.5. Where would -2.5 go? Actually, this is kind of bugging me right here. I'm sorry. Okay. -1, -2, -2.5 would go right here. -2.5. How many could do those two numbers on your own? Okay, how many of you need a little bit of help? Okay, that's all right. We're getting practice with that. Next one. This one's a little tougher. -3 1/5. -3 1/5. -3 1/5. Okay, so I know it's over here on the left side. -1, -2, -3 1/5. We'll just go a little bit past -3. -3 1/5. Yes, ma'am?
I thought you would go like point. I thought you would go like the other way. Like -2. I thought you would put it
Closer to -2 instead of -4?
well closer to like I thought you would put it on the other side of the tick mark.
So like right over here?
I thought you were supposed to.
Yeah, it would seem like that, but that would be for, if it were 3 1/5, you would put 3 1/5 about right here. But negative means you're going further to the left. That's right, that happens. All right, 1 3/4. Positive 1 3/4. 1 3/4. So 1 3/4. So I got that right there. Can you guys see that back there? I think I'm writing kind of small, but.
I'm good. Yeah, I'm good.
Okay.
Seems pretty big to me.
All right. And then the last number I'll have you put, positive 2.5. Positive 2.5, or 2 5/10. Okay? All right. Does anyone need more time to put those points on there? Because we're going to start looking at these. All right. A couple patterns I see here. First of all the numbers that we graphed, the 5 numbers that we graphed, raise your hand if you can tell me what type of number, so thinking back last lesson, what type of number all 5 of them are. You're like, wait, no, they're different, aren't they? No, they're this type. You should know it, hopefully. Chloe?
They're all rational numbers.
They're all rational numbers. Somebody tell me which one, raise your hand, which one of these rational numbers is an integer? Tucker? That was a trick question, Tucker. Which one of these are an integer, or is an integer, I should say. Yep. Sorry, Joey? None of them are. What's the definition of an integer? Raise your hand. Yep.
A whole number or its opposite?
A whole number. So is that a whole number or its opposite? No. So it was a trick question. But now do you know, Tucker? Which one of these is an integer? None of them. Paul? What's an integer?
An integer is a whole number and a whole number's opposite.
Okay, so none of them on there, but they all are, Dylan?
They're all rational numbers?
All rational numbers. Okay, so we're good on that. All right, this number right here, 0, is special because it's neither positive nor negative.
Wait, could 0 be an integer? 0 is an integer on a number.
Yeah, sorry, but we didn't put a little dot over it. So yeah, if I put a little dot there, it would have been an integer. You're right. Okay. The dot tells me that's the numbers I'm looking at. So you see the number line. I can keep going, right? But these dots are telling me I'm talking about this number, this number, this number, this one, and that one. So we graphed it. So that's actually a good question. All right. 0 is neither positive or negative. But every number to the right of 0 is what type of number? Positive. So we can call them positive rational numbers, right? Positive rational numbers are over to the right, and then over to the left? Negative rational numbers, or negative numbers, okay? Excuse me, to the left is negative, to the right is positive. That's something you should know, and if you don't know it, there it is for you again, to help you out. Now, the further I go to the left, what happens to the value of the numbers? They get, Justin? Smaller and smaller and smaller. So let me give you a comparison question. Okay, which number is smaller? Not which number is bigger. Which one's smaller? Daniel, which one's smaller? -3 or +4? Which one's smaller? -3 or +4? Smaller. -3. Okay, that wasn't too bad, right? Daniel's like, thank you. Let me give you another question here. Which one is smaller, Elijah? -100 or 1?
-100.
Wait. Let me ask this question. I'm saying it very deliberately. This way. I thought 100 was bigger than 1. Raise your hand if you could correct my thought process. I thought 100 is bigger than 1. Dylan?
Well, since it's negative, it's less than 1.
Okay, is it true that 100 is bigger than 1? Yes. But -100 is smaller than 1. Do you guys get what I'm saying? So does the negative matter? You think the negative sign matters?
Yes.
It's going to matter the rest of our lives. So we got to make sure we understand that. Okay, good. Thank you guys for your answers. Okay, we're good on that. We're going to move on to our next concept, dealing with the number line. Okay, first thing we're going to talk about is what we call, I feel like we've talked about this with you guys, but maybe not. You're my first 7th grade class, so that's not. Additive inverses. Additive inverses. Can everyone say that term with me? Additive inverses. One more time. Additive inverses. Okay, just being able to say the term really helps me out, because in your homework it's going to say, find the additive inverse. And you're going to say, what's additive inverse? Well, if you're paying attention, shouldn't be too bad. Okay, let me give you two numbers here, and they were actually on that number line. Negative 2.5 and positive 2.5. All right, do you remember those on the number line?
Yes.
You see them graphed with those little circles? Okay, those are called additive inverses. They're also called what? They're also called, what are negative 2.5 and 2.5? So, Joey, be careful. That door was closed. And now it's open. Hold on, guys. Hold on. This is my third year teaching here, and
I'm actually scared.
when I first got here, we used to have a smart board back there, and the previous teacher told me the smart board does some weird things. We don't know why it does it, but now the smart board's gone. But that door, that's not supposed to happen. Okay, Joey, can you close the door? Just be very careful.
Joey's like,
Hey, he's brave for doing that. I'll tell you more about that story later if we have time. Okay, additive inverses, negative 2.5 and 2.5. What else can we call negative 2.5 and positive 2.5? There are other ways you can describe those numbers. Ryder, give me one way. Okay, they're both rational numbers. Thank you. What else? Raise your hand. Yes, Wilson?
They're both decimals.
Okay, they're both decimal numbers. That's correct. Yes.
They're both integers. I mean, right?
They're not whole numbers or they're opposites.
Oh, sorry.
That's okay.
Sorry, I got.
Here's a key word that you've heard before. You just may not remember it. They're both opposites.
I just said. Oh.
Please write this down. We're talking about opposites. So now, how many of you heard the term opposites in this class this year? Right? Whole integers are whole numbers and they're opposites, right? You guys remember that?
Yeah.
Okay. You've probably heard that probably at least last year, probably the year before that, and into previous years. But, Mr. A, why don't you just say opposites? Why do you call them, everyone together? Additive inverses. Because we're going to learn, well, not really learn. I don't mind waiting until everyone's ready to go. Okay. We call them additive inverses because of this fact right here. Ready? So write this underneath. Negative 2.5 plus positive 2.5 equals... Yeah, 0. It equals 0. So this number and what we call its additive inverse added together give me what? 0. In fact, any number plus its additive inverse always gets me. Okay, so give me another rational number that's a fraction or mixed number, either one. Yep. Negative 93.2. Okay, so this is kind of a separate, I don't want to mix those up. All right, negative 93.2. What's the opposite, or I can say, what's the additive inverse of negative 93.2?
Positive 90.
Positive 93.2. Positive. And I can put the plus sign in front of it, or I can leave it just like that. They're both the same value. What happens when I take a number and its additive inverse and add them together? I automatically get 0. Now, some of you might be thinking, Mr. A, okay, I get that, but that just sounds like a fun fact, like something kind of unnecessary, something you find on a popsicle stick that says, hey, a number plus its additive inverse always equals 0. Thank you for that useless info. This actually has practical application for the rest of our math career in algebra, geometry, and a little bit into calculus. This, additive inverses. So we want to make sure we get this. Someone give me, oh, that was a decimal number. Someone give me a fractional one. Fractional number here, and we'll move to the next page. Tucker, give me any fractional number.
1,527 and 3/5.
Say that one more time.
1,527 and 3/5.
1,527 and 3/5. Thank you for that number.
Getting after it.
All right, I'll say this, guys. It is distracting when we give the comments out. So if I hear any other talking, we'll have to talk after class. Okay. What is the additive inverse of 1,527 and 3/5? Yes.
Negative 1,527 and 3/5.
All right. And what are these two added together going to give me? 0. Doesn't matter what number it is. A number plus its additive inverse is 0. Okay. I went over 3 of these examples because in your homework they're going to give you several problems on this, and I hope you remember additive inverses. Any questions on additive inverses?
Yes, sir.
Okay, last one, bonus, 0. What's its additive inverse?
0.
Raise your hand, please, Thomas.
0.
Okay, what's 0 plus 0?
0.
Oh, just 0. 0 plus 0 is 0. We said 0's opposite is 0, so these are opposites, and they add up to be 0, and it still fits our description. Okay. Next, we're going to talk about negative fractions. Negative fractions. We're going to talk about a specific type of rational number. And I'm actually glad we're talking about this at the beginning of 7th grade, because 10th graders don't get this sometimes. And I'm like, didn't this get drilled into you last year in 9th grade? 8th grade? 7th? No, they didn't even hear about it in 7th grade. We get to hear about it, which is good. Okay, let me give you a fraction here, negative 3/8. Okay. Oh my. When you understand what things are written down, how you can say them, it really helps you to understand how to deal with them in different ways that make life easier for you in math. Okay, someone read this for me. Raise your hand, please. Yes. Emma.
Negative 3/8.
Negative 3/8. I can also read it as this. Let's see if you guys can understand what I'm saying. The opposite of 3/8. Is that true? Is negative 3/8 also known as the opposite of 3/8?
Yes.
Mm-hmm. So who could read it to me both ways? Both ways here. Just read it to me just like we just did.
Negative 3/8 and 3/8.
Negative 3/8 and...
Oh, the opposite of 3/8?
Yes, there you go. Negative 3/8 and the opposite of 3/8. Okay, you guys okay with that? All right. This little negative sign can be written in several spots and still make that the same value. And you're saying, what are you talking about? Okay, you see this, and I try to do my best on this, but it's a little off. This negative sign, you see that's kind of in line with the fraction bar or the division bar. You can also write this number negative 3/8. That is still negative 3/8, or the opposite of 3/8. Does anyone know how else I can write? There's one other way I can write it. It still has the same value. Just by moving that negative. 3/8. They're the same thing. Same thing. I don't want to spend too much time to prove that, but opposite of 3/8, opposite of 3/8, opposite of 3/8, all the same value. Okay? So are you comfortable seeing it in any way and still thinking either negative 3/8 or opposite of 3/8? Are you okay with that? Okay, because you're going to see it, and I hope it doesn't throw you off. All right, let me give you an example and see if you guys can help me out. Somebody give me the additive inverse of 1/2. Additive inverse of 1/2. Daniel? Okay, -1/2. Okay, -1/2. Somebody tell me how to write it a different way. The additive inverse of 1/2, how do I write it a different way? So here, what can that equal as well? Yes, Abby? -1 over +2. And somebody give me the third way I can write it. 1 over -2. Okay, I just want to make sure you guys get that. And I'm telling you right now, 10th graders who were in Algebra 2, they're like, wait, you can do that? Yes, you can do that. They're all the same value. But Mr. Ray, I like it like this. That's the only way I've seen it, the only way I've known it. But this might be easier on some problems, and this might be easier on other problems. And we'll get to those as we go through time. Okay, any questions on negative fractions? We're good with that sign. You're okay with that? By the way, guys, I know these concepts seem kind of like, I don't know if you guys think this, but maybe kind of scattered. Like we're talking about number line, then we did additive inverses, now we're doing negative fractions. These are all basics of algebra, okay? So that's where we have to go through them. Next topic, let's go with absolute value. Ooh. Now this is where we get stuck if we're not paying attention, if we don't know how to read what I'm writing. So that's where we're going to have to make sure we get that down. Okay. So write down absolute value. And how many of you have seen this kind of notation, the absolute value of n? You have these long bars and something in between it. It could be a number or it could be a variable. Anyone seen that before? Okay, that gives me feedback, so now we have to start from scratch. All right, this is how you read it. So this right here is red, and I'm writing this for your benefit, is red, the absolute value of n. That's how you read it. The absolute value of n. So once you're done writing it, we're just going to say it, because I want you to get comfortable saying it. And then when you can say it, you can understand it better. Okay, so everyone together, you're going to do this when I point here. You're going to read this as, in just a moment, the absolute value of n. Okay, ready? The absolute value of n. One more time. The absolute value of n. So when you see these little bars, or I should say these big bars, with something in between, this is how you read it. The absolute value of whatever's in there. So the absolute value of n. How many of you understand that? Good, because I'm going to give you one, and somebody will be luckily selected to read it for me. Okay, who will be my first volunteer? Let's go with Paul. You want to read? How do you read this?
The absolute value of 2.5.
There you go. Very good, Paul. The absolute value of 2.5. Okay. How would you read this? Will.
The absolute value of -3 1/3.
The absolute value of -3 1/3 is correct. That's good. You guys good on that?
Yes, sir.
Even if I call on you, you'd be okay?
Yes, sir.
Okay. Trying to get feedback here. Some of you are like this. Great. Some of you are like this. Steady face. Some of you are looking down. Hopefully you can get it down. Okay, so what is absolute value? So now we're going to talk about what it actually is. Okay. It is the distance of, I'm going to use the words correctly for that last example. The distance from 0 to a number. So this is still absolute value. It is the distance from 0 to a number. All right, do a little short number line. Start with 0 in the middle. Let's go just 3 out. Doesn't have to be long. And you can draw the arrowheads, great. we understand that it's going infinitely. Okay, someone tell me where I would put, actually this is too easy. Put a dot on positive 3. Just put a dot on positive 3 right here. Make it nice and visible for yourself. And then put a dot on negative 3. Negative 3. Make sure it's darkened so you can see it. Okay, I'm going to start with positive 3 here, and I'm going to start with absolute value here. So, the absolute value of 3, okay, is really asking me what is the distance of 0 to this number. So how far is this number from 0? How many units? What would you say, Wilson?
3.
3. Yeah, so from 0 to 3, this distance right here is 3. So what's the absolute value of 3? You just write 3. You can think of it, it's 3. So the absolute value of 3 is equal to 3. So if you want to make this a simpler statement, just write 3. Okay, but here's where people get confused, and I need you to pay attention so you're not. I'm going to ask this next question, what's the absolute value of negative 3? So what I'm asking for is what's the distance from negative 3 to 0? What's the distance of negative 3 to 0? This might baffle some of you. You're like, wait, what? Elijah? 3. Oh, so the distance from negative 3 to 0 is also 3. So the absolute value of negative 3 is 3.
Wait,
Kind of strange. Yes, sir?
why not negative 3?
Good question. If the absolute value is the distance, do you ever measure distance in negative values? So let me give you, how many of you are cross country in here? Anyone? Okay. You've had a bad cross country practice. You were only able to run negative 1 miles. Or negative 1 mile. Does that even make sense to anyone? No, like some people are like, well, that means backwards. No, that means negative 1, which how do you measure that? Wait, what are you talking about? There is no such thing as negative 1 miles. Okay, or negative 1 mile, negative 3 miles. You only measure distance in positive numbers, don't you? I went 3 miles that way, or I went 3 miles that way. It's still positive. You guys understand that? So the absolute value of a number is always positive. The absolute value of a number is always positive. Always. Yes, ma'am.
Why would it be 4 if you're like negative 3 to 1 0?
Okay, so this is, you got to take, starting here, 1, 2, 3. I think you counted this number, you said 1, 2, 3, 4, but it's actually 1, 2, 3.
Okay.
Yep, good question. All right, yes, sir?
So it's just like if it was negative 3 and not positive 3, it would go to negative 6 instead of going to 0.
No, it wouldn't go, you can't go negative 3 somewhere. Like, that's the problem. Like, you can never say, I went negative 3 that way. It doesn't compute. Yeah, that's why it's tough to even describe that answer. Yep.
Did you say the absolute value of like whatever number is always a positive?
You could say that. Mm-hmm. But I'm going to throw you some curveballs. So, like, here you're good, here you're good, but there are things we throw out that make it a little bit tougher to think. Okay. Let's see if we can get some of those down. Okay. Gracie, you want to try this problem here? What is the absolute value of negative 3 1/5? So what I'm asking is how far is negative 3 1/5 from 0 on the number line?
3 1/5.
It says 3 1/5. That's correct. Let's go with another one, kind of a strange one. Jack, what's the absolute value of 0? So I'm asking, how far is 0 from 0?
0?
Yeah, it's a 0. There's no distance, so it's 0. Not too bad. And then, Olivia, what is the absolute value of 1 3/4? 1 3/4.
1 3/4.
Oh, okay. 1 3/4. How many of you are comfortable finding out the absolute value of a number so far? I say so far because there's more. Yeah. Okay. this is what I want you to do here. There are two main concepts we've talked about right now, or in this last period, last part of our lesson. Additive inverse and absolute value. Okay, what's the additive inverse? How do you explain that to somebody who maybe hasn't heard that word? Additive inverse, what are you talking about? You could say, oh, it's just the opposite of a number, right? Okay, what's absolute value? How do you explain that? And you might have to explain the definition because that's the way to do it, Dane.
It's the distance of the number from 0.
Very good. It's the distance of that number inside from to 0. There you go. Okay. On the bottom of page 5 in your textbooks. And remember, you're still working your notes because I want you to correct it if you need to. I want you to do numbers 1 through 4. And please listen to me right now. You must read the instructions and understand them before you do it. If you just start writing stuff down, good luck, because it's not going to happen.
Page 5.
Page 5, the very bottom, numbers 1 through 4. Read the instructions. Well, Thomas, do you have a question?
Yes.
Can you read the instructions? And then we'll get your question. Go ahead.
Find the additive inverse and the absolute value of each rational number.
So how many answers do I want on each problem? 2. And you could do it like this. You write one number, comma, the second number.
Can we just do A or B?
You can. Just separate it. Make sure additive inverses first, then absolute value. Yes,
We
sir.
did one on that.
Do it in your note paper. Yep. And you can label it number 1. So this is how I do it in my notes. If I were you, I would do number 1. And then, all right, let's try that first one. What's the additive inverse of negative 4.25? What's the additive inverse? Tucker?
4.2.
You're right, 4.25. What's the absolute value of negative 4.25? It's also 4.25. Mr. A, can I just write it once if it's the same answer? No, because it's not always the same answer, and I don't want you to just guess and just put one number down, hope you get it right. No, it's not always going to be like that.
Like, I have a question. If it says like the absolute value and it's negative 0.2 or 25, wouldn't it be negative 0.25? If it's saying the absolute.
So they're asking, what's the absolute value of negative 2.5? 4.25. So what's the distance of this number to 0?
It would be
Positive 4.25. Yep. All right, do 2, 3, and 4 on your own. I'm going to come by and see how you're doing. You got to have 2 different numbers for each problem. I'm not taking just one. And this is a preview of your homework tonight. That's a tough one, right? So how do you read number 3? Like, how do you read that number?
7 and negative 13.
I know, it seems kind of awkward, but can you move that negative sign to make it something easier to read?
Can you make it like negative 7?
And now you know what the additive inverse absolute value. Sorry?
So put it on top.
You can put it on top if you want. Yep.
You sure it's this one, right? Number 2.
Okay. Additive inverse. So what's the additive inverse of... Okay, that's your answer right there?
Yes.
Mm-hmm. So that's good. And what's the absolute value? It's that.
Okay.
Yeah, you only do up to 4.
Second one, would it be negative 6 or 4 over 5?
Well,
or would it be positive?
Positive, because what's the distance of this to 0?
It's
This is positive. Mm-hmm.
Okay.
I know, it's tricky, but you think of it that way, you always get it right.
So the additive would be negative 6 and 4/5, and then the absolute would be just 6 and 4/5.
Yeah, which one is this? Number 2. Negative and positive, yep.
I'm not sure so far.
Sorry?
You're not doing it right.
It seems like you're putting 2 numbers, you have one possibly negative, one possibly positive, so we'll go through it in class. We'll make sure we get it. All right. Especially, I think it was number 3. Man, I don't like how 3 looks. They could have written that differently. If they could, how would they have written it differently? That may help you out. Yes, ma'am.
I don't understand how to do the absolute value with fractions.
Okay, so here, how would you read this number? Just read just the way it is.
Negative 7/13.
Good. Okay, so what's the absolute value of negative 7/13? So how far is negative 7/13 from 0?
Negative or 7/13?
7/13. Positive, right? You just write 7/13 again. Okay, number 2. I'm just going to call on you. Give me an answer. If it's right, great. We'll move on. If it's wrong, I'll call on someone else. So number 2, the additive inverse. Olivia.
4.15.
Oh, sorry. On number 2. Number 2.
Oh, on number 2.
Mm-hmm. So what's the additive inverse of 6 4/5?
Negative 6.
Negative 6 4/5. What's the absolute value, writer, of 6 4/5?
Positive 6
It's still positive 6 4/5. Okay, number 3, a tough one. What is the additive inverse of 7 over negative 13? Ugh. Nelson?
7/13.
It's just positive 7/13.
Wait, what would it look like? It's 7.
You just write 7 over 13. And you can put a plus sign or you can leave the plus sign off. All right, what's the absolute value of 7 over negative 13? Cam?
7/13.
7/13. Imagine that. They're the same number. All right, number 4. What is the additive inverse of 9/10? Emma? Additive inverse. Negative 9/10. What is the absolute value of 9/10? Dylan? 9/10. You guys okay with that? You're going to do a lot of that on your homework, so I hope you're good.
What was it for the absolute?
9/10. All right. Looks like it's time. Okay, listen carefully. You're going to get out your blank sheet of paper. And a lot of you, I graded your homework from last night, the previous night. And just make sure that you do the problems I tell you. Don't do more if you don't have to. One of you, not in this class, one of them did all the problems. I was like, so 2 through 36 or whatever it was, all. They did them all. I'm like, that's cool, but you didn't have to do that. Okay, so your homework tonight is going to be 8 to 36 even. 8 to 36 even. Just to give you an easier way to remember it, so I don't have to go do 8 and 9, then 10 through 13, then 14 and 15, skip 16 through 7, just to make it nice and easy, and those are good problems. And that's going to be on pages 3 and 4. 3 and 4 of your workbook. 3 and 4 of your workbook. And again, if they did the problem for you, you don't have to do it. But in this case, there are none of those.